Okay, so 2-3. 2-3 is using coordinate proof using distance with segments and triangles. Okay, so I'm not going to require you guys to do a complete coordinate proof. The essential question on this section is, how do you write a coordinate proof? I am basically going to show you how they come up with the distance formula and the midpoint formula, and I think what you really need to pull out of this is what is the distance formula and what is the midpoint formula. Okay, so how can you use those to prove things about triangles and whatever else they ask you about. Okay, so this is going to be the walkthrough of coming up with the distance formula. Okay, and of course the midpoint formula. Alright, so to derive the distance formula, we're going to start with points. Okay, so we're going to say that point J is x1 and y1, and K is x2 and y2. So if we're given these 2 points, and we know that they're not the same point, we're going to prove the distance is this. Okay, so maybe the first thing you write down in your notes is this right here is your distance formula. Okay, distance equals the square root of the quantity x2 minus x1 squared plus the quantity y2 minus y1 squared. Okay, so, alright, this is going to walk us through this. So it says locate point L. Okay, there's point L. So that JK is the hypotenuse of a right triangle. Okay, so it pulls this down, and it basically is your idea of your rise over run. So we could have gone up and made a right triangle this way, but they went this way, so that works. Okay, so the coordinates of this. Okay, so the x value is the x value of your x2, and the y value, how far up, is your y1. Okay, so point L is x2, y1. Okay, so now it says find JL, so there's your L again, JL and LK. So this is asking us for a length. Okay, so if I'm going to go and find the length of J to L, okay, since the y values are the same, all I have to do is figure out the distance from the x2 to the x1. So basically, I would just subtract those two values. Okay, so that would just be x2 minus x1, and that would give me the length of the LJ, or the JL. Okay, to find the LK, so that's this height, I'm just going to find the change in the y distance. So that's going to be y2 minus y1. Okay, which hopefully should kind of look familiar to you. We're kind of utilizing the idea of slope. That's the same idea. Okay, so since we have this right triangle, and we're talking about the lengths, naturally you're going to pull in Pythagorean's theorem. Okay, so if you recall, Pythagorean's theorem is a squared plus b squared equals c squared, right? Okay, c squared is your hypotenuse. Okay, so we're basically doing the same idea, but instead of using single values, we're using these distances that we've come up with. Okay, so we can kind of pretend like the a distance is the distance from JL. So this is your value for your A. Your B is like your LK. So this is your B distance. Okay, so we're going to try to figure out what the C distance is. Okay, which is where this is going to be derived from. Okay, all right. So basically, what we're going to do is we're going to set this up. So let's start with JK squared. So JK squared, that's what we're looking for. We don't know that value yet. Okay, that's going to be equal to JL. So we just found JL and it's squared. So x2 minus x1 squared plus LK squared. So LK we found was y squared minus y, or y1 minus y2, excuse me, I said that wrong. Okay, so if I'm going to use this equation now and just simply solve for the jk is here, I'm almost isolated, I just have to get rid of the square. So how would you get rid of a square? Okay, yeah, you square root. So it's just going to be the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so boom, there is the proof behind the distance formula. Okay, so that's pretty cool. Okay, so make sure you write that down, you have the distance formula, so maybe instead of writing jk, write distance equals that. Okay, so we're going to do the same thing. I'm going to prove to you the midpoint formula. So perhaps you remember midpoint is you add the x's, divide by 2, you add the y's and divide by 2, and that gives you your midpoint. Okay, so we're going to do the same idea, so this time they're going to use the points A and B. Okay, so A is going to be x1 and y1, B is going to be x2, y2. Okay, so we're going to get to this piece, we're proving this. Okay, so it says, what is the horizontal distance from point A to point B? Okay, so again, we're doing this horizontal distance. Okay, so horizontal distance from A to B, so A, B is going to be x2 minus x1. Okay, the vertical distance, okay, oh, sorry, that's not AB. Let's call this C. Excuse me. It's gonna be a big point. So AC. Okay, and then the vertical distance that's here, we'll call that BC. This is going to be your difference in your y, so y2 minus y1. Okay, so the horizontal and vertical distance from A to M must be half. Okay, do you see how this can be half? So from here to here, this is going to be half of this. And this vertical distance is half of this vertical distance. So what is the horizontal distance from A to M? So if our horizontal distance was x2 minus x1, all we're going to do is just divide that in half, right? Okay, so you would just write x2 minus x1 divided by 2. Okay, vertical distance, that's your BC. We have half of that is y2 minus y1 over 2. So now to find the coordinates of M, add the distance from step E to the x and y coordinates of A and simplify. Okay, so they wrote this out for us. Okay, so we would take the x1 value, so that's the x's, and we're going to add to the middle. Okay, and so all they do here is, okay, we got to have a common denominator, right? So you have 1 over 1, 1x, get a common denominator, so that's 2 halves. So then you can add your tops, get 2x1 plus x2 minus x sub 1. So now you can combine like terms, you have a 2x sub 1 minus an x sub 1. So that makes 1x sub 1. And you still have your x sub 2. So that's how you get this x value. So your y is going to be kind of the same idea, but basically just y's instead here. So you would have a y sub 1 plus your midpoint. So y2 minus y1 over 2. Okay, so then you're getting a common denominator, so that would be 2y sub 1 over 2 plus y sub 2 minus y sub 1 over 2. Then you can add your tops together. So 2y sub 1, they do this in 1 or 2 steps, plus y sub 2 minus a y sub 1 all over 2, and then you combine your like terms, so you get y sub 2 plus y sub 1 over 2. Boom. So simple, right? Okay. So there's the proof behind it. So nothing else, make sure you write down the equation for midpoint. Okay. So, this goes through proving the triangle Midsegment Theorem. Okay, so let's see. I'm not going to walk through this whole thing. I'm just going to kind of go and explain to you what it does in fact prove. Okay, so if we have a triangle, calling it PQR here, and a midsegment is XY, so meaning X is in the middle of P and R, and Y is in the middle of QR. This midsegment is going to be half the length of this opposite side. So if this length is, let's just pretend for a second, 5, then this length here would be 10. Okay, so that goes through, and it just uses the midpoint formula to make that conclusion. Okay, and it also uses the distance formula to make that conclusion. It's kind of just another add-on to what I just showed you, but in a little bit more detailed way, I guess. Okay, so that should be enough information for you to complete your worksheet for 2-3.